All right, so here we are. We're going to be talking about our lab questions from our density lab, the lab that never ends. All right, so question number 1 asks you about following your sources of error and how that would affect your determined densities. So number 1, we're going to go through A together. I won't give you the final answer, but I'll show you how to work through what I call a calculation framework. And this basically is showing how data would impact your final results. So letter A says the regular solid is hollow. Okay, if it's hollow, what is that affecting? Well, that's going to affect our volume. If it's hollow, our volume would be actually calculated to be too high. So if our volume is too high, we're calculating it, we're going to find out what that calculation does. So if hollow, the calculated volume, because this is our regular solid, is too high. We're not using numbers here. We're just using generalities. Okay, so what else are we using volume for? If we're going to worry about our density, well, we know that density is equal to mass over volume. So if our volume is too high, that means our bottom part of our density calculation is too high. Well, what does that mean? Ooh, it's in the denominator. So if our denominator is too large, that means our density is going to drop. So we would say calculated density is too high. Okay. I actually did give you the answer for letter A. I want you to do the same thing for B and C. Go through where that source of error begins and how that trickles down to your final answer for density. I want you to show me something. I want you to either write it in words. You can write it in generalities like I'm doing, where you're just using abbreviations and up and down arrows. If you need to and you want to plug in sample data, that's fine. But A, we did, so hopefully you get 100% on that. B and C, I want you to try on your own or with your lab partner. I don't need complete sentences. You can write just quick little statements if you need to. All right, so number 2 is asking about your density and your data that you plotted on your graph. Number 2A, how would this plot be used to determine the density of any concentration of a sodium chloride solution? So that's asking me, 2A, if I gave you 23%, how would you know what to use? How would you use your graph to figure out what the density is? And then in letter B, I actually want you to tell me, if you have 35%, what does your data tell us the density is? See, even when I'm recording, I make mistakes. Okay, so those are just 2 quick little hints. Your lab is due on Monday, September 15th. Okay? If you have any questions, I will be here for a little while after school on Friday or on Monday morning. Take care, guys.